Hello YouTube University students, and welcome back to Opa's Garage. And today in Opa's Garage we are going to build a engine rotator for an engine stand. I've already built this one. This is one that I built quite a while back. The engine that is sitting on this Harbor Freight 2,000 pound engine stand, say what you want about Harbor Freight, but for no more than what you pay for their stuff, most of it holds up pretty good. But at any rate, this is a 2001 7.3 Power Stroke in long block form, which is basically just the block, the crank, the internals, and the head sitting on it. This engine weighs between 800 and 900 pounds. I don't know if you've ever tried to rotate an engine by hand. When I say rotate, I'm talking about taking the engine from this position and flipping it upside down to like install a crank or anything like that. It's a big pain in the butt. Usually it takes 2-3 people and everybody's nervous as heck. So I built this rotator for this one a while back. Basically it's a 9/16 socket. Put it on there right there. I'll show you how it works here in just a second, but the parts that are used are a S-cam and slack adjuster from a semi-brake system. I'm going to go ahead and set her down right here, and I'll zoom in just a little bit so that you can see. Much easier than trying to do it manually. I've actually got a longer ratchet that I normally use, but this is just your standard 12-inch Craftsman half-inch drive ratchet, and as you can see, it turns the engine over relatively easy. So in the past, the engine that I was usually assembling, I would put on there, and then the engine that I was disassembling, or if I was taking parts off of another engine, I would have it on this these 4 posts that I made that I can actually raise that engine up and lower it down. That's in the lowest position there, and I can raise it up 12 inches. But it's kind of a pain in the butt doing it that way, so I've decided, as many of these as I do, I'm going to go ahead and build me another one of these rotator assemblies. So went to Harbor Freight. I think it was $159. Bought me another 2,000 pound engine stand. Got me another slack adjuster. Got me another S-cam. Those are actually throwaway parts from my job. I work on tankers that haul acid, and so our tolerances are much stricter than what most shops use. But if there is a heavy truck shop somewhere in your area, if you stop in there and ask them nicely, they would probably just give you an old used slack adjuster and an old used S-cam, and you could probably get them for free out of their scrap. Hello YouTube University students, and welcome back to Opa's Garage. And today we're not in the garage, we are in the shop where I work, and we are going to build a rotator for an engine stand. There's the engine stand. It's a Harbor Freight 1 ton. I've only got part of it here because that's the only part that I needed. And then the parts that we need to do this job are, we need a slack adjuster, which there are several different styles of slack adjusters, and we need an S-cam. And these are parts that come off of like a big semi-trailer. Get underneath here, put a little light on the subject. These are the brakes on these big trucks and trailers. Take the brake off. There's where your S-cam is. It actuates the brakes. And then on the back side of the S-cam is your slack adjuster. So a lot of times these get changed in different shops. These are generally rebuildable, but most shops don't bother rebuilding them because they are relatively cheap. So instead of buying a brand new slack adjuster and a brand new S-cam, if you have a shop like this in your area where they work on heavy equipment, heavy trucks, heavy trailers, you can probably stop in there and just ask them
for a old worn out S-cam and an old worn out slack adjuster, and they would probably be willing to give you one for free. Like I said, there are different styles of slack adjusters. These are referred to as knuckle busters, and the reason for that is when you're adjusting the brakes, you tighten it up to a certain point and then you back it off. With this style, when you back it off, you just have to give it some extra pressure and it feels like you're stripping the gears out. Whereas on this style here, this is your adjustment nut and you tighten it up to a certain point, and then there's a little paw inside here that does not allow this to back off, and you have to take a special tool or a screwdriver and shove it in there to hold that paw out, and then you can back it off easily. The reason that I prefer this style here is because you can remove this piece right here, just pull it up out of there, and then the slack adjuster will turn freely either direction. It won't be harder to turn one way or the other. This one here, I don't know the part number, but it came off of a trailer that we worked on not too long ago, and it has a 9/16 head. This is a gunite slack adjuster. It's got a 7/16 head, and the part number for it is AS1140. This is a Meritor. It has a 3/8 square head, and they make a special tool. It's actually an 8-point tool, or you can buy an 8-point socket to do the adjusting. Also, you can eliminate having to pull out on that paw by removing the shaft out of here, and then this will spin freely. But the downside is you only have a 3/8 head, whereas here you have a 9/16 head. But this is a Meritor slack adjuster, and the part number is R801074. These are relatively inexpensive. They're, I don't know, $50. These are generally a little more expensive, $80 to $100. And then the next thing that you're going to need is you're going to need an S-cam that has the proper number of splines. This would be a 28 spline, and it will fit in that one, this one, this one. And we will cut the head off of this, probably right around there. And then those splines will go into that slack adjuster, and that slack adjuster will attach here to the back of this post on the engine stand. And so the first thing that I got to do is we've got to cut this off flush. Need a cut-off wheel. You're going to want some hearing protection, and of course eye protection, and maybe a pair of gloves for the sparks. I generally just take a marking pencil and mark the line, pull it out, cut it off, and I'll do that real quick and then we'll continue the video. Okay, so we've got that piece cut off there. As you can see, I started with a brand new cutoff wheel, and that's what's left of it. So get yourself a good quality cutoff wheel, because this is thick, hardened steel. Well, it might not be hardened, but it's thick steel, and it'll burn through 2 or 3 cheap ones. But once you have this piece cut off, then you want to go ahead and you want to take your S-cam and slide it in there, and slide your slack adjuster on your S-cam. Remember, on the back side you're going to have a snap ring and you're going to have a washer there, so kind of leave it stick out a little bit. And then normally what I do is I usually try to cut the S-cam off so it's flush with this plate. Now remember, when you have your engine on there, you've got probably a good 1.5 inches sticking out past this plate. So if you leave it a little bit long, it's better to have it a little bit long, and then end up having to grind some off or cut some more off, as opposed to if you cut it too short, now you have to start over with another S-cam. Okay, there are many ways to cut this S-cam to length. One of the ways is a chop saw. Another way is with a cutoff wheel, like what we used a little bit ago to cut the piece off of the engine stand that bolts to the engine. The way that I prefer is a bandsaw. Turn that baby on, set your cut speed. And then you get a nice, pretty straight cut. So, what's the next thing that we need to do? Well, the next thing we need to do is we need to figure out a way to center that S-cam shaft in this hole right here. And need to make a couple little blanks like that. So what we do is we take the old trusted tape measure. See, outside diameter is 3 inches, inside diameter is 2 3/4, and then the S-cam shaft is 1.5 inches. So she's done. So we need to make outside diameter anywhere from 2 3/4 to 3 inches, and then the inside diameter, inside hole needs to be 1.5 inches so that it fits that shaft really good. So how do we do that? Okay, well, the first thing you want to do is get you a good hole saw kit. Lennox makes great hole saw kits. I'm pretty sure if you live in a big enough city, you can probably find a place to rent one of these. If you have to buy a whole kit, you're going to be spending a few $100s. In which case, I would recommend you just buy the two hole saws that you need. So get in there and you dig out the hole saws that you need. I already got the 3-inch out, got the 1.5 inch out. Got us some 1/4 inch plate steel here. And what I like to do is I like to start with my 3-inch, and as you can see, I've already got part of that cut. And then before it cuts all the way through, I take the 3-inch out, put the 1.5 inches in, and then I go ahead and I cut the 1.5 inch hole all the way through. And then take the 1.5 inch hole saw out, put the 3-inch back in, and at this point you will no longer need your drill bit guide, because you actually have a recessed area for your 3-inch hole saw to guide itself down through there, and that makes it a whole lot easier than if you were to go ahead and cut the 3-inch slug out and then try to clamp this little area down here and try to get your 1.5 inch hole cut. So we'll do that and then we'll continue the video. Okay, as you can see, the 1.5 inch plug is out. There's the hole right there. And I've got the 3-inch hole saw back on there. Spray some foam on it. And that one's a little bit louder, so I'm not going to videotape, but I just wanted to show you how the groove that's already in the metal, the bit will ride down into that groove. You don't have to worry about it walking around and not giving yourself a good cut. Okay, so quick recap. What have we done so far? Well, we've cut the excess off of our engine mount plate. We cut the head off of our S-cam shaft, and we made 2 little inserts so that we can center the S-cam shaft in the engine mount plate. Now, when it comes to making these, do you have to have a drill press? No, but it makes it a whole lot easier. You can put those hole saws in a hand drill, and you should be able to make these parts using just regular hand drill and a lot of oomph. The other thing is it doesn't need to be 1/4 inch thick. No, you could probably get away with something a little bit thinner. I like overkill. I like to build it so that it doesn't break. And so, yeah, you could probably get away with some thinner material. I wouldn't go too thin. But the next thing that you want to do is, these, of course, come painted, powder coated, or whatever, but you want to get all that paint or powder coating out of there. I used just a regular angle grinder with a wire wheel attachment, got down in there and got most of the paint removed. And so then the next thing we're going to want to do is start assembling things and welding. That'll go there. The shaft ain't going to stick out that much. Why don't I go ahead and tack everything together and then I'll show you. Okay, before you get crazy with the welder, you want to tack everything into position just to make sure that it's all going to work properly. a couple tack welds up here, kind of make sure it's sort of centered. Does it have to be perfect? No. Next thing you want to do is take your slack adjuster and slide it on there. Make sure that you've got enough room on the back side of it that you can put a flat washer, and then you'll have your retaining snap ring. As you can see on your slack adjuster, those splines are recessed in there enough to where when you weld that all the way around, you won't have to worry about your slack adjuster not sliding on there far enough. The splines are recessed enough that it'll be just fine. So now that you're happy with that, the only thing left to do is weld the rest of that up solid, and then move on to the next step of, once we attach the slack adjuster, we need to hold this end. And so what we're going to do is we're going to drill a hole here, going to drill a hole here, and we're going to run a tube all the way through there and out to the edge of the slack adjuster, and then we'll put a bolt through there, and then we're pretty much done. The next thing you want to do is you want to pack you some paper or a wedge or something up underneath here, because you're going to want to have this faceplate tilted forward, because when you have weight on there, it's going to want to tilt forward. So you want the front down at the bottom, and you want the back up at the top. That's what the little paper is for, is to wedge it in there so that it's in that position. Next thing you want to do is you want to mark the center of your upright, and then you want to take your slack adjuster, slide it into position, slide it on there, get you a transfer punch, stick it in that hole right there, line it up with your mark that's in the center, take you a hammer, make you a little mark, and right there is where you're going to drill your hole. Okay, so to make sure that you get that hole somewhat straight, because you won't be able to measure from here down and from here down, because it will be different because of the angle of the engine plate. So what I did was I put everything all back together, and then I put a square up there and just kind of tried to line it up with the punch, and then make a mark on the square tubing, so that it doesn't have to be perfect. You're going to make that hole big enough that you can assemble everything, get everything tight before you weld that tubing in there with the bolt that's going to go through. Okay, so that didn't work out quite the way we thought it would. Drilled the hole in the back, made the little mark there. When we tried to drill from the back out through the front, we discovered that there is a welded seam right up the middle, and we were hitting that welded seam. So what I did was I took a speed square and basically just lined the speed square up, and then came around here, made a mark partially across the front, and then I measured from here over to the center of the hole, which was 1 3/8 inches. Measure from here over to the center at 1 3/8 inches, and use the punch to mark my location for my hole. Drilled the hole, and as you can see, if you stick a drill bit in there and kind of step back, you can see that it looks pretty close. Once again, doesn't have to be perfect. I'm going to put that tubing through there, and then before I weld everything up, I will go ahead and tighten everything up so that it will be at the angle that I want it to be at when everything gets welded. At this point, you want to partially assemble everything, so you want to slide your engine plate in, and you want to put your slack adjuster on, put your washer, it's actually called a shim, on, put your snap ring on so that everything's held in place, and you want to put your little piece of paper up underneath there so that it's tilted at the proper angle. You can see there's a gap down here, there's no gap up there. And then you want to get you a step bit, and you need to make the holes big enough for your piece of pipe to go through. Now, This hole right here is a 1/2 inch hole. So the piece of pipe that you use has to be 1/2 inch on the inside diameter so that you can get a 1/2 inch bolt to go through the pipe. And then you just slide the, like I said, you open that up enough to where you can get this pipe in there. And then voila. I don't know why I ground that. I need to mark it right here so I can grind it there. But at any rate, now once you get everything all put together, you want to go ahead and put your bolt on, get everything good and tight, and then you'll want to tack weld there. You want to tack weld there, take your bolt out, and then weld this solid, weld this solid. I do not recommend just trying to like weld a bolt to this square tubing. I don't know if you can see that or not, but the square tubing is not very thick. And I plan on putting a 800 to 900 pound 7.3 Ford Power Stroke engine on this. I've already built one of these. I know it will handle that, even though people say, oh, it's a Harbor Freight engine stand. It is rated for 1 ton, and it is built to be able to handle 1 ton, which is 2,000 pounds. But if you tried welding just a bolt right there, I think that after you started using it a little bit, you're going to end up with your bolt ripping this thinner gauge square tubing. So I recommend drilling a hole, getting you a nice heavy piece of tubing to run through there, welding everything up good and solid, and that way you won't have any problems. All right, we got our piece of pipe welded up in there, both sides, ran the bolt through, got the nut on this side. If you don't put that bolt and nut on there, if you don't put the bolt on there, then as you're trying to rotate your engine, then the slack adjuster is just going to spin around in circles. So that holds it stationary so that when you turn this bolt here, the assembly will rotate. Like I said, you want to remove this. To do that, all you got to do is grab a little pair of vice grips, clamp it on there, and then as you pull that out, grab that and pull that out of there. It just pops right out of there. And now you have an engine rotator. And it spins freely going one direction, and it spins freely going the other direction. So hopefully you got something out of this video, and hopefully you decide to build yourself an engine rotator. It's really not that difficult. It doesn't take a lot of time, doesn't require a lot of money, and they are very useful. And if you did get something out of this video, please hit the like and subscribe buttons. And until next time, keep living your best life. Get out in the garage and fix something.